how it's regulated, and the second part's really irrelevant. You know, how is breathing rate regulated is the actual question. And then the second question from a couple of years ago, the mechanics of breathing, which allow a performer to fill their lungs during exercise. So we've got breathing rate regulation, we've got the mechanics of breathing, sorry. And then we've also got another question from 2 years ago. We've got figures that show, or some scientists trying to show a diagram of an alveolus and blood. Gives us values for the partial pressure. P stands for partial pressure of oxygen in the alveolus as compared to the partial pressure of oxygen in the blood. Same for carbon dioxide, comparison between alveolar partial pressure and blood partial pressure. And it says use the information to explain how oxygen and carbon dioxide move between alveolus and blood. And then talks about the large surface area for diffusion that occurs in alveoli. Name 2 other features of the lungs that assist diffusion. So these sort of questions are quite common. So what do we need to know about for this sort of stuff? Okay, it's revision. Hopefully you could answer them straight away. Also linking to this one, we can talk about spirometers, these machines that measure lung volumes. So here we've got a spirometer trace. Ask you to identify lung volume B. We've also got a question asked about lung volume A. Okay, so these sort of questions we need to answer. So in terms of the lungs, the mechanics of breathing. Air moves from higher to lower pressures. It always does. So what we need to do is to change the pressure inside the chest, and we do that by increasing the volume of the chest. This is physics. If you increase the volume of the chest, you'll lower the pressure. We increase the volume of the chest by breathing in. And we breathe in by getting the diaphragm to contract and the intercostal muscles to contract. And before the question comes in, it hasn't got to be external intercostals, and the previous time we asked this question we just accepted the term intercostals. So the 2 main muscle groups working in normal breathing are the diaphragm and the intercostal muscles. They will increase the volume of the chest cavity, that will lower the pressure inside the lungs, and the air gets sucked in. In order to breathe out, just get those muscles to relax, and the weight of the ribs and those muscles will return the chest to its normal size. So breathing out is actually a passive process. The only other thing you might need to know in the exam is what happens when we're exercising, when we need to use other muscles to increase the volume of the chest cavity much quicker and make it much larger. And then we use other muscle groups such as, well, go on, name 2. Write down 2. 2 muscle groups that are used during exercise to increase the rate of increase in volume and the size of the increase in volume. And you should have put things like the scalenes, which are in your neck, everyone's favorite muscle group, the sternocleidomastoid that joins the side of the ear down to your collarbone almost. You may have put the pectoralis minor muscle, and you may have put, I've not put it in this slideshow, but you may have put the abdominal muscles as well. All those are correct, and probably during the exam that would be maybe an extra 1 or 2 marks for naming 1 or 2 of those. I think I'd probably want my students to be able to name 2 of those extra muscles involved. So the mechanics of breathing is all about volumes and pressure by muscle contractions. Okay, lung volumes. There are 5 lung volumes you really need to know. And on the screen you can see that the left-hand side has 3 lung volumes named: the inspiratory reserve, the vital capacity and residual volume. On the right-hand side it gives a definition of the 2 that are missing. So what I want you to do in the next minute as revision is to identify that top definition. What's the name given to the lung volume that is the amount of air moving in and out during normal breathing? Write it in the space where that yellow block is. Underneath that, what's the lung volume called that described by the amount of air that could be used when breathing out? And then for the inspiratory reserve volume, the vital capacity and residual volume, please give a definition. And I'll give you a minute to do that. Everybody okay? Lung volumes, amount of air moving in and out normal breathing is your tidal volume. Amount of air could be used when breathing out is your expiratory reserve. Often get asked the question, would we accept expiratory reserve or expiratory volume? I'd like all three words. That makes it completely correct. I think if someone put expiratory reserve, I'd possibly expect the examining team to mark that correct. If they put expiratory volume, possibly, and don't quote me, that might be wrong. Put all three and be correct. It'd be best. All three words. The inspiratory reserve volume, well, that's the previous definition when changing the word out to in. It's the amount of air could be used when breathed in. The vital capacity, harder. You need to get the word maximum in there somewhere for vital capacity. Vital capacity is the maximum amount of air you can breathe in and out. And the residual volume is the stuff that's left inside when you've breathed out. You cannot empty your lungs. Okay, let's take those 5 volumes you might be asked to define in the exam and add them to this typical spirometer trace. Nice pretty colours. So we need to know on the left hand side what's the blue volume. From the top to the halfway down, the pink volume, or the lime green volume, or the yellow volume, or the white volume, or the orangey browny colour, peach, whatever you want to call it, volume at the bottom. And you can identify them because it's not a question that's going to be, it's easy to write down the initials. You know, we're not marking it that way. So I've had a request to go back a slide. Sorry, Kesgrave. Yeah, is that better? Thank you. Okay, so please, take in those 5 volumes. Tidal volume, call it TV. Which one of those is TV? Vital capacity, VC. Which one's VC? Etc., etc. Give you another 30 seconds to complete that. I've had a question from St. John's. Would we accept vital capacity is IRV plus ERV plus TV? No, I want it to be identified as vital capacity, but that idea that vital capacity is the IRV plus the ERV plus the TV could be examined, and we'll come to that when we go through this slide. You've had your minute. Tidal volume, the blue bit down there. If you get stuck on these sorts of things, look for the residual volume, where there's no air being shifted. That makes it easier to understand where we are. When you found the residual volume, the peachy bit at the bottom, it means that breathing out must be going down towards the peachy bit. So yellow is your ERV, and the black line, the black curve, shows you that expiratory reserve volume, which means the IRV is the white bit at the top. And then, as the guys at St. John's said, IRV plus TV plus ERV give you the green section, which is the vital capacity, and leaves us at the bottom with the residual volume. Okay, clever people, what's happening to the vital capacity on the right hand side? What's causing that, first of all? And then once you've said what's causing that, what actually happens to your to your tidal volume on the right hand side of the spirometer trace? And hopefully you've said that on the right hand side we've got exercise taking place, so the tidal volume changes. The obvious change is that tidal volume increases. Less obvious, but it is there when you look at it, is the peaks are closer together, so we actually breathe deeper and more frequently. Two results of exercise: tidal volume increases and it occurs more frequently. Trick question, that, a 2-mark question sometimes in the exam. I didn't mean trick question, you know what I mean, difficult question. Okay, it was about the gas exchange, the same values as we had on the question paper that we looked about 5-6 slides ago. Here we've got alveolus as a circle, blood as a tube. In the alveolus, the partial pressure of oxygen is about 100 thingies, don't worry about the units. In the blood it's about 40 units. Partial pressure of carbon dioxide, 32 in the alveolus, 46 in the blood. Okay, so with an arrow going up and an arrow going down, please show on the left or right hand side which way the oxygen goes, and give me a reason why alongside it. Similarly, on the other side of this slide, which way does the carbon dioxide go and why? And hopefully you've put something like one gas goes that way, and the gas that goes that way is oxygen, and the oxygen goes that way because the partial pressure of the oxygen in the alveolus is higher than the partial pressure of the oxygen in the blood, or worse to that effect. You get the direction and some idea of the difference in partial pressures. And as a point of interest here, so you understand, the correct term is partial pressure, but the examiners will accept the word concentration if you use it. So there's a higher concentration of oxygen in the alveolus, a lower concentration of oxygen in the blood. Okay, that's okay, we'll accept that. The important word here is the word diffuses. Diffusion takes place. That could be maybe a 2nd mark. You know, oxygen goes from higher to lower, and the process is called diffusion. As against the student that says it goes from high to low, or it just moves from high to low, hasn't used the word diffusion, may not get the same marks. If we've got that one nice and simply done on the right hand side, surely by now you've got the other side done, that carbon dioxide goes from blood into the alveoli, into the lungs, because there's a higher partial pressure of carbon dioxide in the blood, and therefore it diffuses the alveolus. You got the other way around and says there's a higher partial pressure, or sorry, a lower partial pressure in the alveolus for carbon dioxide, you still get the mark, obviously. Kesgrave, yeah, PP will do me. And I just say, you can use the term concentration in the exam, it does get marked correctly. I suppose things might change, by the way. We might get, I don't know, nasty and want other terms, other words, but at the moment we're okay. And I've been getting an echo, and I've just worked out where it's come from. It's come from my iPad. Okay. Why does diffusion work? So here we've got 5 reasons why diffusion works, with missing words, and they're nice simple words. So what have we got in terms of alveolar and capillary membranes? What's short between the membranes? What's the big difference? What's the large contact? And tell me about the way that blood flows. Do you want to have a go at filling those in? And that might take you a bit of discussion with your colleague next door. Have we got the idea that these alveolar and capillary membranes are very, very thin, incredibly thin? Have we got the idea these membranes are very, very close together? There's a very, very short distance. In fact, you do very, very well to find a gap between them. They are adjacent. The big difference is in terms of concentrations, or proper word, partial pressures. Note that the first two bullet points, the thin membranes and the short distance, are structural features. The large differences are a functional feature, not necessarily a structural feature. Large contact surface area. Here's a debatable point for you. If the exam asks for, give 3 reasons why diffusion works so efficiently, if you put large surface area, would the examiners mark it correct? Because it's not necessarily true. It's the contact surface area. And then finally, blood. Blood flows very, very slowly through the blood capillaries in the lungs, really slowly. And that gives more time for diffusion. So maybe in the exam, the idea that blood flows slowly would be awarded a mark, and maybe that would be the same mark on the mark scheme as, therefore, there's time for diffusion. Okay, the other question at the beginning of this section was about the control of breathing. The big thing here is that people are getting quite good at these sort of questions. So often these are now getting prefaced with some of these bullet points taken out almost. Yeah, tree orchid, moist lining is in the mark scheme, but I just didn't put it in. I sort of thinking about past exam papers. Why diffusion works is never going to be a 6-mark question. Just go back to the previous screen. It's never going to be a 6-mark question. It's just going to be a 3-mark question-ish, maybe a 2, maybe, no, I don't think it would be a 4. Maybe that's a bit, now would you give 4 marks for that simple topic area? So because of that, I didn't want to put too much stuff down. I don't think it's worth learning 6 things about the diffusion process. More likely just learn 3. So I left moist out for that reason. But yeah, it would be in the mark scheme. There would be that in the mark scheme. Hope that answers your question and the reason why it's not there. I think there's a tendency sometimes to teach too much when there's no demand for that much knowledge from the exam papers. I don't think they need to know, the students need to know 6 things about why diffusion works. And I apologize that I've cut it down to 5, having left out the moist one. If you've constructed the idea of this moist layer inside the alveolus, then I do apologize. Okay, control of breathing. The first 3 bullet points are the ones that everyone should know. Just snap, snap, snap. Levels of carbon dioxide in the blood increase. This is detected by, the names of the detecting systems are the chemoreceptors. These should just roll off your pen, roll off your tongue. And we have a respiratory center in the medulla. Now some centers, some students are getting really good at rolling these things off their tongue and off their pen and onto the paper. So we could maybe make these sort of questions harder by saying breathing rate is controlled by the levels of carbon dioxide that are detected by the chemoreceptors. Then what happens? So we actually, those first two bullet points are disappearing from mark schemes. And I think that may have been the question we asked in the summer. So what you need to know is the more detailed stuff at the bottom. Okay, so the respiratory center sends nerve impulses. It sends nerve impulses along a sympathetic nerve, and again that's a common regulatory system. Sympathetic nerves are the ones that speed things up. It's sympathetic nerves that speed up the heart rate. It's sympathetic nerves that cause the redistribution of blood that we're going to do later. The actual nerve involved, for those that are really clever, is called the phrenic nerve. And that would be on the mark scheme either alongside sympathetic or maybe on a separate mark. Depends on what the examiners think this year or next year or whenever that question comes up. The nerve impulses go down not to the lungs, they go down to the muscles. We've already named those muscles on a previous slide. That's the diaphragm and the intercostal muscles. Same again, no need for the term external intercostals. And that then causes contractions, and probably if we were talking about exercise, there'd probably be a bullet point in the mark scheme, should you need it, to name the additional muscles, the scalenes, the sternocleidomastoid, the pectoralis minor, and the abdominals that may cause this more rapid and more profound increase in lung volume. Okay, so it's the same sort of stuff. Would I accept accelerator nerve? Is a question from St. John's. I'm thinking, because we've had this question recently and I don't think it was on the mark scheme. So no would be the answer. Sympathetic, and I'm trying to remember, I think it was the May exam. I think sympathetic and phrenic were the alternatives, and they were on the same bullet point in the mark scheme. And I don't remember seeing accelerator nerve in the mark scheme. Someone somewhere could probably check. Okay, still moving on.